Hello, ladies and gentlemen.
Hello.
Welcome to our session, Baking a Microservice Pie. So, as you can tell, there's a play on words, the pie and the pie. Hope you got it, yeah? Welcome to Devoxx, Belgium. Hope it's not too early for you. It was a bit early for us because we had to set up all these things, so we were here at a very early stage this morning.
Yeah, that takes some time to set up.
And we hope that you're ready for this 3 hours deep dive session. Thanks for joining us.
Hello guys, my name is Roberto. I'm based in Portugal. I work for this company called Tommy Tribe. I'm not sure if you heard about it, but basically we're one of the companies behind Apache Tommy. Other than that, I've been working a lot on the software industry for like the last 10 years. Mostly working with Java technologies, Java EE, in the last 5 or 6. Other than that, I run my own Java user group in Portugal, Coimbra. That's where I'm living at the moment. I'm also a Java champion. Running the VJUG book reading club. We're gonna have a session later in the afternoon if you want to join us as well. And I think that's it.
My name is Antonio. I'm slightly older than this guy, so I've worked slightly longer than this guy. He runs the Coimbra Jug somewhere in Portugal. I run the Paris Jug in the central of the universe in Paris. And I'm also a Java champion, and I'm also come from the Java EE background. So today we're here to tell you a story, actually. This 3 hour session, it's basically talking about our journey through the microservices architecture. Like most of you, we will see later, but we go from customer to customer, we do microservices. It's the new trend, the new place to be, and we are always surrounded by people. There's always an expert on the database, there's always an expert of the network, there's always an expert on security, there's always people around, so microservices tend to work if there's more than 100 people involved. But we actually wanted to be what's so-called a full-stack developer. So we took those Raspberry Pis with all the network cables, with all the things that can go wrong, simulating a data center, and we will explain and show you how we will put microservices into play in those pies with the network issues, with the security issues, the load balancing, and all these problems. And doing microservices when there's only a small team can be quite tricky. Mm-hmm. So we will progressively build microservice architecture. As you will see, it's quite simple in terms of business. And the 3 hours will mostly be trying to solve all the technical problems. So we have 9 demos. And we will go from one problem to a solution. And then we will eat another problem. And we will try to find a solution. And we will eat a problem. And a solution.
Yeah.
Kind of.
And probably going to end in a problem.
So we will end up building a very basic app, we will show you. But totally distributed, scalable, etc., etc. Because it's a 3 hour session and we will be covering a lot of technical topics. If you have a question, ask it now. Because if we wait for the very end and you ask something from the beginning, it might be out of context.
Yeah, just shout if you have a question. Yeah. Interrupt us whenever you want. We'll be happy to answer anything that you might want to ask us right on the spot.
So I'm going to show you the final demo. So this way you know what we will be building. As you can see here, there's a few colors. as there are on the Raspberry Pis. So I don't know if you can see, guys, but we have orange, red, purple, and black. So this is what we're going to put at the very end of the demo. So basically the black Pis at the very top are the clients. So there's an Angular app, but there's 3 injectors. So we have the 3 Pis here in the middle, the black boxes, are clients injecting load. Then on the red ones, we have one microservice, the book API. So it's an API to create books. Very simple. There's 2 of those. The book APIs, when you create a book, this API needs a number. So it goes to the orange boxes where we have the number API. It's an API that gives you a number. Okay, so in terms of business, we have the red, the book API, that needs the orange, the number API. Of course, we need a central gateway. We will show you why. And as you can see, the purple, we have the gateway on the purple and console on the purple. We will explain you what those elements are. And we have ELK, so Elasticsearch, Logstash, and Kibana running on the Mac because it can't run on the Raspberry Pi.
Yeah. Do we have any Elk team over here? No? Oh, we have a couple of people from the Elk team, right? Can you help us run Elk on Raspberry Pi? Because we need 2 gig to run it, so it's kind of impossible. So we have to run it on the Mac.
So the ELK is on our box. Okay, yeah. So those guys are sending us logs. Okay. So I'm going to show you the demo. Okay, so this is what we will be building. In terms of UI, we try to make an effort. So it's Bootstrap, as you can see. It's very nice, as you can see, and it's Angular. So here I have this famous number API. So as I said, it's a public API. I don't need to log in. And basically, if I hit it, it just gives me a number. Okay, very simple. So this API is running, there's 4 instances running on the orange Pis. Then I'm going to create a book. So I need the book API. Here, as you can see, I can view it. So I do a HTTP GET. I can edit it, change things around. So that will be a put and a delete. And I can create a new book. So here I'm going to create The Lord of the Ring, author Tolkien. And as you can see, there's no ISBN number. But when I create it, there is an ISBN number. Why? Because the book API needs the number API. That's it in terms of UI and business. Now, we have different things. First of all, we have console. We will show you why we need that. Console tells us where all the book APIs and the number APIs are. So as you can see, there's 2 here. There's not 8, there's 4, but
yeah, 2 book APIs and 4 number APIs.
These guys are sending us logs. So here we have a dashboard that tells us throughputs, exceptions, error codes, and it should change every 5 seconds because, as we said, the black Pis are clients doing post, put, and delete. So the clients are creating books and deleting books, updating books. That's why the dashboard is moving. And finally, we will show you a gateway because some APIs need to be authenticated, others are not. So we will show you how this works. So that's it. Okay, in terms of business, it's quite simple. And then we will mostly concentrate on the technical parts. Back to the slides. So that was the final demo, and we will be building that block by block.
And we'll give you more detail about the final demo when we get to it.
So in terms of architecture, of course, like everybody, we do microservices. We have monitoring with ELK, configuration also. We can change things on the fly. We will show you why. Discovery, load balancing. The architecture is completely stateless. So it can go to one API or the other. Okay. There's a load balancer there. Circuit breaker, because we will show you that sometimes things can go wrong and how to fix that. We will plug and unplug cables. And security, as I said, some APIs are public, others are not. In terms of hardware, we need our Mac mostly because we need to show you slides, some demos, and because of ELK. That consumes huge amount of memory, and it wouldn't work on the Raspberry Pi.
And a way to control all the Raspberry Pis.
And we have 12 Pis each. Why each? Because things can go wrong.
Yeah.
So we have 6 servers. That's the orange and red Pis. We have the 2 purple, the infrastructure. Then you can come at the break and have a look at them if you want. We have the 4 clients that hit load and have the Angular app. 1 router, 3 switches, and dozens of cables that we will plug and unplug. In terms of software, quite basic. Java for the back end, Angular for the front end. We stuck to the micro profile with some extensions. So in terms of servers, we use Tommy and Wildfly Swarm. For the web part, we use Nginx for the Angular, ELK in terms of software. We will mostly use the Netflix stack with Eastrix and Ribbon. So we will show you how. Console for the registry, and the access gateway for the security using TimeStream access gateway. And for the infrastructure, Hypriot OS is running on the Pi, so it's a very light OS, mostly suited for Docker images. So that's what's running on the Pi.
So it basically allows you to run Docker images on the Pi. So these guys from Hypriot came with this really small image that you can flash to put it on the Pi. So it's super useful to run any Docker image over there. The only thing that you have to worry about is that since the Pi needs to run on a different distribution, you need a specific Docker image to run on the Pi. So for instance, Java, you need the Java for Raspberry Pi to run over there, so you cannot just run the regular Java. Same thing for other services.
So mostly those Pis run Hypriot OS, and all the demos will be us building Docker images and pushing the images to the Pis thanks to Ansible. So we will also show you Ansible. We rely a lot on Docker. Docker Compose too. We might do a few demos, but that was mostly for us to help us. In terms of database, well, there's enough trouble with the cables and the Raspberry Pis that we didn't want to put data. At the very end, we will tell you what we've used and what we didn't use. And we didn't do any heavy data, business logic, DDD, keeping simple, concentrating on the technical aspect. So that's what we will be using and building during these 3 hours. Okay? Let's start by a quick introduction on microservices. Have you heard of microservices?
Yeah, well, probably it's easier to ask who hasn't heard about microservices.
Yeah, who hasn't heard about microservices?
Okay, no one. That's awesome.
Do you know how big is a micro?
Like 1,000 lines of code? No? 500? 200? 10?
2?
1. Just one single line, like
Who
10K
plays
characters
with
or something.
microservices on a day-to-day life? Okay, quite a
Okay.
few. Who runs microservices in production? Okay.
A few.
Yeah.
Who would like to run microservices in production?
Who would like?
Okay.
We will ask the same question after the talk,
Yeah.
and we will see.
Let's see if you would like to do that.
Who likes microservices? Yeah, because
Yeah.
you can charge more your customers.
Yeah. Who doesn't like microservices?
No?
Only two of us.
Well, only 2 of us. Who suffers with microservices?
Just a few. Okay.
Oh, come
We'll
on,
try
guys.
to do this demo and then we'll see.
Okay, so what do people mean by microservices? And I think that, we don't have an answer, and nobody has an answer. So we just went online and took all the answers of the planet. So a microservice is a small autonomous service working together. Small enough, but not too small. I love this one. Can be written in 2 weeks. Not 3, 2.
Not 1.
No, 2. Single responsibility principle, domain-driven design, hexagonal architecture.
What's an hexagonal architecture?
I don't know, but I love it.
Does anyone know what an hexagonal architecture is? Oh, please guys, come over here and do the presentation.
No, but
Okay.
we will explain it. But the best line I like is the one I wrote at the very bottom. Blah blah blah. So we won't be talking much about microservices because, first of all, we don't know what it is. There's also these 2 pizza that fit in a team. But yesterday night we had 1 pizza each. So so let's be
Actually,
serious.
I don't think people see our tweets and we're not eating pizza. So.
Yeah, that's true. So let's be serious for just one slide. Why are we going that trend? It's true that when you isolate things and you make them small, but I don't know what small means anyway, but it's true that you can iterate quicker, deliver features quicker. Because it's smaller, the team can be more agile and go faster, and you can have everybody with you, the DevOps guys, the database guys, etc., etc. You deliver business as a feature, as a service. Sorry, that's what we did. Even in our small example, one focused on one API and the other one focused on on another API. The good thing, and that's what we've done, is you can scale services independently. We have 4 instances of the number API on the orange boxes and 2 book APIs on the red ones. So you can do that depending on your load. You have all your logs, you have all the metrics and the monitoring, and then you can fine-tune things. Address unpredictable loads. That's exactly that. You can, because the architecture is completely stateless, if we need more pies, it's just a matter of piling them and it will work. And also, when you go to the cloud, even though, the cloud can be an expensive place, so the more services you have, the more you pay. But it's also good for that. And we will end up, telling you where not to use microservices to, because as you will see, it can be a bit of a pain. Okay, so let's start simple. We have shown you the final demo with everything. Now we're going to be building blocks by blocks.
And we'll tell you what problems did you run to.
Yep.
Yeah.
Each section will end up with a problem, and the section after trying to solve this problem. So let's start simple. We're going to start with one API, the number API. And we have one Angular client. We can do curls, but we wanted something more visual, and we need a UI. So we use 2 pies. One pie will have the number API running on Wildfly Swarm, and another pie will run the Angular app running on Nginx. And now we're going to show you how to develop, run, and deploy this simple first step on those pies. So the architecture will look like that. The client will be running on a black Pi, and the orange, that's for the number API, running with Wildfly Swarm. So there's several ways to develop microservices. You know, I don't know here, does Drop Wizard?
Drop Wizard users? A couple? Legume? No Legume?
Oh, no
there's
Legume,
one
yeah,
person.
oh, just one, okay.
Vertex.
Vertex, that's quite popular.
Okay, couple.
Cool.
Spring Boot. Oh, yeah.
Okay, a lot of Spring Boot.
We have to call Josh Long here then.
Yeah. Microprofile.
Microprofile. Oh, not that many.
Not that many.
Others.
I know you.
Other thing. Okay. Yeah, we don't. There's a couple of other things that you can use, but we tried to pick the most popular ones. Maybe we forgot something, but. So
we took it simple for us because we come from Java EE world.
Mm-hmm.
We wanted, to be honest, at the beginning, we wanted to write a few services written with all different technologies.
Yeah, even Node, but
even Node.js. Because when you go to a microservice talk, you know, you have all these beautiful slides saying, pick whatever language you want.
Yeah, but I don't know how to write Node, so.
If you have a team with 100 people, that's fine. But to be honest, the more languages you have, the more technologies you have, the more databases you have, the harder it is to integrate them. So we just stuck to very basic microprofile because it comes from Java EE, and we only use, you know, in terms of code, we have nothing. So we use JAX-RS, CDI, and JSON-P because we send a JSON. And the microprofile comes with extensions. But actually, we didn't take them all. We took the configuration, we will show you. The microprofiles come with the security, else check, circuit breaker. But we didn't use those. We used the Netflix things. Basically, the microprofile, we took the JAX-RS endpoints and the configuration, because we need to configure our endpoints. So that's what we choose. But again, you know, we are not here to talk a lot about Java. It's mostly how to integrate those things and solve.
Even for most of you that are using Spring Boot, you'll see that it will be very similar on what we will do on Spring Boot. Maybe we can change the presentation or the code to do Spring Boot.
Yeah. So the number API. Let's start simple. A JAX-RS endpoint. It generates number. Okay, so it's a math random. Nothing special. And we just do an HTTP GET on numbers/book. That's all. It's running on port 8084 on the local machine, and then we will see how we deploy them on the Raspberry Pis. Sorry, guys, it's for the photo. Thanks.
Thank you.
And that's important. We won't be here showing everything, but this number API will have to be accessed by the Angular app as well as the book API. So what we did is we created a Swagger contract and we generated the Angular and Java code. We will show you. So in terms of code, that's it. You know, the number API is just an HTTP GET on /numbers/book, and it returns math random. That's it.
And it's a microservice, so it needs to be small.
Yeah, and we built it in 2 weeks. So
not one and not three.
You know,
two.
as I said, in terms of business, we are, you know, it's quite pretty simple. We are running it. This one, we are running it on Wildfly Swarm. So for those who don't know, Wildfly Swarm comes from Wildfly, JBoss, Red Hat. It's open source, modular. That's the good thing with Swarm, is Wildfly Swarm, sorry. It's split into fractions, And in this case, we just need the JAX-RS fraction. So think of it as a JBoss, but pretty small. And at the end, we will have an executable jar. Instead of building a war and deploying into JBoss, we took it upside down and we have an executable jar.
Kind of like Spring Boot with a fat jar.
Yeah.
Same thing.
If we have time, we could, even tell you why jars are better in development but terrible in production when we use Docker, etc., etc. But because the images are small, we took that because it's simpler for us in terms of development. So that's the backend, one service running on Wildfly Swarm. And for the front end, I have a pretty big experience in Angular now. So I thought, let's do those pages with Angular.
Not me.
Yeah. So we choose Angular with Bootstrap so it doesn't look too rubbish because we had bad web designers. So the Angular app will be running on port 8080. Again, we will deploy it. We'll slowly change ports and everything. It invokes, it just does. It invokes the number API through HTTP. Thanks to the Swagger contract. Swagger, it's an important piece in our architecture. It's now called the Open API specification. And basically, it's a way to document your APIs. So what do you call? What are the parameters that you call? What are the status code that it can bring back? So this contract describes your API, and this contract is written either in JSON or YAML. And there's even extensions, annotations that we can put on our code, either JAX-RS or Spring Boot, and it generates automatically the Swagger contract. So what have we done? We've just added API, okay, saying to Swagger, this is the API, blah, 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 and we can give it, descriptions and so on. And here, we say that we have one operation. And again, we can give it a name. It returns a string or it returns an object. It can return a 404, a 200. So we pack annotations like that on our code.
And it took us 2 weeks to do that.
And at the very end, it creates a Swagger contract. So here we have the number API on localhost 8084. Number API/API, and then you go to numbers. And then you do HTTP GET, and that returns text plain in forms of a string. So we have documented those APIs because then we have an ecosystem of tools and UIs and text editors, etc., etc. So the Swagger is quite big in terms of tooling, and the community is quite big, and so on. So what we did is we used Swagger CodeGen. So Swagger CodeGen takes a Swagger contract, and it generates code, either client stubs or servers. In several languages, because we're going to use the same contract to generate TypeScript for the client and Java for the book API. So they can both call the number API. One line, we have the Swagger CodeGen. We give it the Swagger contract. We say, please, can you do some TypeScript for us? And bang, bang. It creates that. So in our TypeScript, as you can see, there's the URL of our API, and it creates a method called generate book number because it takes the same name of the Swagger contract. And here it does an HTTP GET, and if it's a 2 or 4, returns undefined. If not, it returns the book number. So we took this bit of code and put it in our pages, on our Angular. You hit the first wall very, very quickly. Cores. You know, think of it. We have one client running on one server and the book API in another one. And you have the browser and you want to access the Angular app that calls the book API. So the first problem that you hit is cores, cross-origin resource sharing. That's like that. You know, we cross the boundaries of the server, and the first thing you're going to get is it doesn't work. And you look at your logs and you go, oh, yeah, cores. Because Number API and the Angular app are running on different servers. There's several ways of solving cores. You know, you can put proxies, you can do things. If you stick to JAX-RS, you can even put a filter. Each time you evoke an endpoint, it will add cores headers. We chose the servlet filter because it's easier and it allows to put cores, you know, headers on everything, not just REST. So this is what we've done. On the Number API, we created a servlet filter, and we just add all the access controls. And with that, it works. We just need to allow it on the web XML. Demo time. I'm going to do it locally on my Mac, and then we will deploy it on the patties. So what do we have? If I go, so all the code is on GitHub, we will give you the URL. There's demo 1, 2, 3, 4, 5, 6, 7, 9. So we are on demo 1. And basically, if I'm going to switch to the, so I'm not going to show you all the code because, you know, we just took small bits on the slides. So here I'm running ngserve. So actually the Angular app will not be running on Nginx yet. It's on Express. It's easier to develop, and then we will package it into Nginx. And here I'm on my service. So I have the Number API. I'm going to use Maven, and of course I'm going to skip the tests. So we use Wildfly Swarm. There's a plugin, a Wildfly Swarm plugin, that will package your WAR file into a jar file. So here, if I look into target, I have the original WAR, that is 769Ks. You can take this WAR and put it on JBoss, on Wildfly. Or, and that's what we've done, Swarm creates a fat jar with JBoss inside. That's why it's 93 megs. So if I do Java jar and I run this executable jar, for those who are familiar with JBoss and Wildfly, you can see the same logs. Wildfly Swarm is ready, and I could do a curl, but because I'm very good at Angular, I created a couple of web pages. So I go on port 4200. Hoo-ha. And here I just have a blue button. And when I press it, it does an HTTP GET. At this stage, I think you can applaud, because
That's awesome.
to get the button the right size, it was a bit tough, I have to say.
It took us longer than do everything else.
And here I can, I show you the Swagger contract. So, as you can see, I can do a get on numbers. So the demo one is very, very Very simple. Okay, so now I'm going to give, I'm going to give, well,
Control to me.
yeah. And Roberto will show you how to take those things and deploying there on the pies.
Okay.
Switch.
Awesome. Okay. So for deploys, as we already seen, we have a bunch of Raspberry Pis. Actually, we have 24 of them. So as we already told, they're running IP out OS. So if you have some Pis stacked at home, they're very useful to run these kind of things. So let me just do like a parenthesis over here. I do love to develop on this particular setup because that allows me to quickly deploy stuff over there. Probably it's much quicker to deploy stuff over here than deploying on Amazon Cloud, and it's much cheaper. So like this entire stack is probably like $500, and it's yours forever, and you can do whatever. So you can just go and unplug cables and see what's happening. So it's very useful to do stuff over there, especially when we pack with Docker. As we've seen before, we do require some specific Docker images to run on the Pis because of the Linux distribution that you have to run over there. But other than that, Java runs fine. Pretty much most of the stuff already has Raspberry Pi images to run over there. So the IPROT guys, they have an Nginx Raspberry Pi image. They have MySQL Raspberry Pi image. They have a console Raspberry Pi image. So, and if there is none over there, you can run your own. But most of the times, you're able to find a Raspberry Pi image on the Docker Hub to run whatever software you want. One thing that's important over here is that we do use a local registry. So I'm going to give a little bit more detail about that. But basically, for us to push stuff into the Pis, we use Ansible as well. Who here knows about Ansible? Okay, a few of you. Just going to do a couple of Ansible stuff for people that don't know about it. But we end up picking Ansible because they have a good support for Docker. They have this Docker plugin that allows you to push images to wherever hardware you have, so it works very well. So we're happy with that. And the Docker or the IPROT OS also supports Docker Swarm. So we could definitely have used Docker Swarm over here, but we prefer to use a more manual Ansible scripts with just Docker, so we can exactly control what we were deploying on each Pi for demo purposes. But if you're doing like all of these in production, and if you know what you're doing, you could definitely have used Docker Swarm over here. So, okay. So the Raspberry Pis, we already been through that, so I'm not going to repeat that. So for Docker, our build also generates Docker images for Number API for the Angular app. So the Angular app actually is packaged into an Nginx Docker image, so it can serve all the HTML and JavaScript. And also on our build, we do provide a Docker Compose file, so you can run that locally, or the Ansible script, so you can deploy them on the Pis. If you want to like have that setup, or if you want to run your own setup, you can definitely do that. And yeah, for building all the Docker images, we use the Maven Fabricate plugin. So it's a very useful plugin. It allows you to like build multiple images at the same build and deploy them to a Docker registry. So Docker registry, we don't use Docker Hub, especially because we're doing these demos and we do need to have a fast connection. So basically, each demo that we're going to do, we're going to generate a Docker image. So I'm going to do this for the first couple of demos, and then I'll do it offline, so you don't see it all the time. But the idea here is that if you're running your Docker registry locally, then you don't have to go online and grab the Docker images to push on the Pi. So it will be like an insane thing. I'm generating Docker image here. I have to push it to Docker Hub, and then I have to grab it to Docker Hub to pull it back here again to put on the Pis. It's kind of like a way too big of a travel to have over here. So Docker Hub, I think, is too slow for this kind of demo, so we choose to have a Docker registry for that. And basically speeds up your deployment. You can just deploy that to, basically it works like your own local Maven repository, but for Docker images. And this runs on port 5000. So for building, and I'm going to switch over here, so I'm going to start to build right away. I know this is black, let me, so here we go. I'm just going to increase this a little bit. Okay. So here I am.
Put it at the top, maybe. Yep.
Okay, yeah. So this I'm here on my demo 1, and here I'm just going to do like a plain, not this one. So I'm just going to run that one over there. So that's just an alias to run mvn clean install, no tests, doesn't matter. But basically here is running, so it's pretty boring, but I'm just going to do this one time. And this basically is building Number API. It's going to generate Docker images for Number API, both to run on a regular box and to run on the Pi. So you need 2 separate images just for the base image because of the Linux distro. But other than that, the images are exactly the same. So
now it's pushing to the local
registry. So when you see over there, that's pushing to our Docker registry. And I'm also, as you've probably seen, maybe not, I'm running this in parallel build. So Java is already done while Node is still building. So basically you're waiting for Node over here. And then there you go. So what we did over here, we just generated the distribution file for this demo 1, which was what Tony showed you on your local host. Now we have the Docker images to run both on your box or on the Pis. Both of the images were pushed to the Docker registry that we're running locally over here. And then when we push the Ansible scripts for the Pis will go try to grab the Docker images from the local Docker registry. We'll just grab them and update whatever is running over there. So I'm just going to run that right now because it takes a little bit of time. So I'm going to show you the Ansible script as well. I'm just going to leave this running. So, but basically what we're doing over here is just going to connect to whatever Pi I'm running on the Angular app and whatever Pi I'm running with the Number API. It's going to go over there. It's going to see if there is a Docker container already running. If it's there, it's going to stop it. It's going to download the new version. It's going to update it. It's going to start that Docker container. So while that is running, I'm just going to continue here on the slides a little bit. So,
can you show the Docker registry, maybe?
Yeah, of course. So Docker registry. So the Docker guys, they have. Let me open a new tab over here. So they have an image that you can use, so you can create your own Docker registry locally. So it's not anything fancy. So if you go over here, you can see the catalog of the images that are on the repository, which basically is just a JSON response. So at this time, you have a repository called Baking Angular, Baking Book API, Baking Number API, the Baking Simulator, and one image with the TriStream access gateway. One of the things we also done over here to simplify is that we didn't version our Docker images. So we could have done that for a version for each demo, but the idea over there is that we will just fill up all our Docker registry with all these versions. So what we do is we'll just smash whatever Docker image is there with the latest version, and it will work just fine. So let's see if this is already done. So yeah, so the Docker images are already pushed to the Pis. I'm going to show you.
As you can see, there's two images.
Yeah. So you see like stuff here in green and yellow. So the yellow ones are the ones that were updated, and the green ones were not updated. This is syntax, or this is behavior of Ansible. I'll kind of tell you a little bit about it. So let's go here to the slides again. So for Ansible, we can definitely automate all the tasks with that. So let's just say if I want to see all my Pis I can definitely do like a ping all to all my pies, and I see if they all are running. So it shouldn't take long, hopefully. There you go. So we have 12 pies. I'm definitely able to ping all of them. And and then you use a playbook. So the playbook is just a list of tasks of Ansible that allow you to just say, hey, I want to run this playbook and I want to run this list of tasks over there. So sometimes it includes not only running Docker image, but sometimes creating a folder to copy files over there. Then we can expose the Docker volume and stuff like that. But for this particular demo, it's just very simple, just a Docker image that we put over there, and that's it. So this is just an example. So for those that are not familiar with Ansible, you start with a host group. So a host group is you have something called a host file, and in the host file you can. I'm actually going to show it over here, so it's just a little bit easier. There you go. Host. Nice time for idea to do some garbage collecting. Okay, never mind. Let's see if this recovers. No. Anyway, the host file is just a way that you can set up, let's say you have like a group, in this case called services. On that services section, I can say the services are pi 1, 2, 3, and 4. Those are the host names of the pies. And then over here, I can say for all the pies that belong to services, I want to run this task, which is deploy number API. And then it uses the Docker container plugin of Ansible. You can just set up every flag that you can set up on the Docker command line. You can set up over here, so you can set up the Docker name. Of course, set what Docker image you're going to use, but set up the container name. If you want, what's the state of the Docker container? If it started, it's just going to restart. So you cannot see it over there, but there's a pool. So the pool equals true means that. Oh, okay. Awesome. I learned a new thing over here. But basically, the pool will tell you, okay, I want to try to search for a new image of this Docker image on the Docker registry, and if it finds one, it will just download it and update it. And in the end, you have like a when, so it will just basically it will fix this deploy to that particular host name on the pi. So in this case, we're deploying to pi-grom-server-01.
And the restart is important because when we push a Docker image into the pi, we want it to start.
Yep. So deploying to the pies, we built this deploy YAML file, which basically just imports that particular one. So it will be important for the later demos where we have multiple things being deployed. And then you just use this command, Ansible -playbooks. You say what's the YAML file, which has all the tasks that you want to run. And you say what are the host files that you want to use. So you can have like multiple host files. As long as they have the same groups, then you're able to change the host names very easily on where you want to deploy. So what we're going to show over here on the pi is exactly the same thing that Antonio showed, but hopefully it will work on the pies. So now I'm going to go over here to the store, and okay, not found, but this is to be expected. Just need to refresh this a little bit. Okay, so I'm not sure you're not able. I'm not sure if I'm able to increase this, but there is pi-client.01 over there on the address, and we have store demo1 over here. So I can do exactly the same that Antonio was doing. I can grab some numbers over here, and to actually show you that this is actually running on the pies, what I'm going to do is I'm going to this other terminal, and I'm going to SSH to the pies where that is running. So as you've seen on the Ansible script that was running on pi-grom-server.1, so I'm going to SSH over there. I'm going to put password. Okay, so are you guys able to see this?
Yeah.
Okay, cool.
enough.
So I'm going to do like a docker ps. Now I'm able to see that I have the baking number API, which has the version Raspberry Pi in it, running over here. This is coming from Docker Registry, the local Docker registry that we just created over here to set up things. Running on port 8084. And let's show some logs. So let's do docker logs.f. So generating a book number. This was at 8:35:59. So let's just generate a couple over here to see if that log changes. Yeah, so from 35 to 37. So
We are not lying.
Yeah, we are not lying.
It is running on the Pi.
This is
I
actually
promise.
running on the Pi. Actually, not sure which. I'm gonna do like a small trick over here. I'm not sure which.
Are you mad?
Maybe.
You don't do that. The network never fails.
Okay, let's see if I'm able to grab a book number now. Let's go numbers. Pending.
Fantastic. It failed. Fantastic. Just unplug the cable.
So
Well, that's the good thing.
That was just to prove that I was actually running on the Pi. So.
Now, at the very end, we will plug and unplug things with the load. It's
Oh
quite
no!
funny.
Actually, it was able to recover, so I got the book number now.
Wow, how clever we are. Okay. So, as we said, we are building things slowly. Then it will go at a faster pace, but we want you to have the basis settled. We have one API and one Angular app. Then the entire idea is we want one microservice to talk to another one. So we have one number API that gives us number. Now we're going to introduce the book API. And remember, when we create a book, when we do an HTTP post on the book API, it invokes the number API to get a number. Book API invokes number API. And we still have the Angular client because it gives you a bit of visual. And I'm proud to, do Angular and show the world that I can do front-end design. So we're going to use three Pis. How do we deploy and make it run? So the architecture now will look like that. We still have, the clients are the black Pis, so we have the Angular on the black. Now the Angular will be able to still go to the number API, but what we want now is to go to the book API, running on the red Pi, invoking the number API. So that's the architecture of the demo 2. So microservices need to talk to each other. There's plenty of ways of doing either synchronously or asynchronously reactive messaging. In our case, we made it simple. We just do HTTP GET. Okay, so the two services talk through HTTP. How do we talk in HTTP from one service to another one? Well, there's several ways to choose from. You can do it by hand. It's just an HTTP call. Apache has the famous HTTP client. There's, of course, a Jaxorus client API that we could have used because we are using Jaxorus, but we didn't. We used Netflix Feign, and we will show you why. Because, at the very end, you'll see how well it integrates with each Eastrix and Ribbon. So we didn't do it by hand or using the Jaxorus API. We are using Feign for this call. What is Feign? Feign is a Java to HTTP client. It's written in Java. Netflix has plenty of tools written in Java. It's inspired by all the guys, the HTTP client from Apache, the Jaxorus. It's just an HTTP call, but as you will see, it's slightly more clever. It reduces the complexity. As you will see, just one line of code. It works with Jersey, which is our implementation, actually. And it works with REST and SOAP. we use it with REST. So the book API, it's a JAX-RS endpoint, like the number API. Same kind of code. It does CRUD on books. So actually, there's an entity and a database. It's in memory, but there is a DB. So we do get, post, put, and delete on /books. And the book API is running on port 8081. So we have 8081, the book API, 8084, number API. This is what the book API looks like. So for those of you who know JAX-RS, we go on /books, we inject the repository because we need to put stuff in, in the database. And when we do a get with an ID, we get one book. When we do a get, it returns all the books. That's what you see on the page. And what we will be using later is the post. So at the moment, I take the book, I persist it in the database and return the URI of the book. And it's here that we will put the code that invokes the number API. So a basic REST endpoint. This one is running on Tommy. So number API, Wildfly Swarm, book API on Tommy. Tommy, for those of you who don't know, come from the Apache world, so Tomcat and all the Apache, BVAL and OpenJPA and so on. It's open source and it's supported also by those guys, the community, but also Tommy tribe. And same thing, we will be using the FATJAR approach because it's easier in development. It's not good for deployment, but for development it's easier. And again, we will have a Swagger contract. We'll generate some code for the Angular. We do the same. So here the Swagger contract is longer because we have post, put, and delete. Oh, and it's the generate book number. So there's a typo here. Sorry. This time we will again use the Swagger code gen. And as you can see, Swagger code gen can generate TypeScript, as we did, Java, C++, and all these things. But also it can generate some Feign code. So that's nice. We don't have to do much. And that's what it does. It generates an interface with the generate book number. So the idea is the book API will call this method. And this method, there's a bit of Feign magic, but it does a get on numbers book, so somewhere, externally. Sorry. And then, so that's the interface, and the implementation is just a Feign builder. So here I'm saying, again, I'm on the book API side, and I'm saying, well, if you want to return a number API interface, build it with Feign using this base path. So here it's hard-coded. This is where the number API is. And that's it. So now on the book API side, it's quite easy to invoke an external service. I just go, please build the number API interface. It has a method that returns a string. So in this way, I can set the ISBN number on my book. So Swagger code gen creates all the plumbing, and the book API just need a couple of lines of code to invoke an external service. Demo, okay, local demo. Oh, it's a bit funny. I'm gonna do that here on my laptop. So now I will go to demo 2.
Yeah, sir. Okay, the question is the call to generate the number API is synchronous. Yes, at this time, yes.
So I'm going to go to the client, the Angular. I'll do ng-serve again, so it can. Here I'm going to go to the services, and now I have two services. So I'll start with the number API. I do a Maven clean install. It's going to create a FAT jar, and now I'll go to the book API. Again, Maven clean install. On one side, I have one FAT jar running Wildfly Swarm, so I just go Java jar. And now the book API is Tommy, but also has a FAT jar. So now I have Tommy running here, Wildfly Swarm running here, my Angular app running here. So if I show you, so I go back to localhost. Okay. So now I have a couple of extra pages. I still have the number, so I can still go straight from the Angular to the number, but also I have the book now. So as you can see, I can do a HTTP GET on one book. Here I can do a post, John Doe. And more importantly is when I create a new book, it creates ISBN number because it invokes with Feign, the other service. And I even have the Swagger contract of the book API, which is bigger because I can do get, post, put, and delete on a book. So now the question is, Roberto, can you do that on the pies?
I'll try.
Go for it.
But clap,
Easy.
Clap, clap. He was able to do that. So.
And have you seen the blue button? How nice it was. I'm an Angular master.
Okay,
now.
so let's see. Let's try to do it on the Pi. So I did save you some time. I didn't want to put you over the trouble of going for the Maven builds and the Ansible script. So I already run that. So let's see if that works on the Pi. So now we have 3 Pis involved. So one is running the client, the Angular client, as we did before. Another one is running the number API service. And now we have a new service, which is the book API that's running on another Pi. So the yellow ones are the ones that were updated. So I'm running the Angular on Pi client 1. The book on PyGround load balancer probably is not the best name, but that was the one name that I had at the time. And the Grom server 1 is running the number API as we had before. So now if I go here to my store, so now I have the store demo 02, so that's fine, it's over here. That's running on, not sure if you're able to see that, but it's running on Pi client 01 8080. So I'm going to books.
Number is still working?
First. Yeah, I mean, cool. It works right now. So let's see. I seem to have some books over here already. Oh, which book is this one?
Beginning Java E7. Oh, a very old book.
Oh, by Antonio Goncalves. I wonder who that guy is. And let's try to create a new book to see. So I'm going to do like this awesome book, and the author is going to be me. I want to write a book as well. And here, probably 2020. Yeah, I don't know. Maybe that one. Probably that's when I write a book. And I don't know. Maybe a drama one.
Yeah, dramatic.
Save. Okay.
Oops.
Oh. What happened over here? So I have like something over here. I have I'm not able to increase this, I think, but I have like a 500. I wonder why. So let's see the response. Oh, that's this big of a stat trace.
Oh.
No, what should I do? Let me see what's happening on the logs. So now I'm gonna have to go here to when I'm running the book API. So I think it's this box. Docker PS, this is running book API. So let me see the logs. Okay, there's an exception over there. Connection refused. Why?
Oh, that's when service book
Executing
API
get
invokes.
localhost 84, but Antonio, we're not running
Localhost.
the book API on the same box.
Yeah, it's a different box.
Did you hard code the host name over there?
Yes, I did hard coded the host name. Is that bad?
Yeah, it is bad. I'm not able to run that on the Pi.
Yeah, but you can look at the logs, you know.
Oh, awesome. Yeah. Well, it's a pain. I have to like shell script on the Pis and then have to look on that. Well, okay. So as you can see now, we start to run into the first few problems, right? So it does work on my box, on Antonio's box, right? Works on my machine, but it's not working on my Pi. So we definitely gonna have to fix that.
And the problem now is there's one Pi, and we knew more or less where the service is. But when you live in the microservice world, you're not going to look at all the logs of all your servers.
Yeah, now imagine that for some reason you had these running on 20 boxes, and then you forgot to change on one of the boxes, and then you have to like manually go in on each single box to see the logs, to see which one is failing. That's crazy.
So I think it's time for demo 3 then.
Well, yeah, definitely. Let's see what we have over there. So gonna have, so if you guys don't mind, I'm just gonna have these running first.
Clever.
Yeah, so just gonna run in the background while we're gonna talk a little bit about demo 3. So what's next? So basically we have two problems over here, we think. So we have an issue where we have hard-coded hosts on our services, and we definitely need to fix that. And we could have done that right now, but we think that's better if we start monitoring our system first. So we actually got this exception. It was easy to understand, but we prefer to start monitoring first, then we can fix whatever issue we find. So for monitoring, now we have several microservices. We only have two. They're deployed in two boxes. We can have them deployed on multiple boxes. And they are running on several Pis. So in this case, you're only running 3, but it doesn't matter. You can run it on all of them. Something might go wrong. Let's see how we can monitor all of them. So this is our architecture at the moment. So it doesn't show that in the bottom, but basically one of the things we're going to do over here, we're just going to put like one monitoring stack. It's going to run on our Mac. Maybe if you've chose another thing, you can run it on the Pis, but we are very happy with what we choose. So central monitoring that we need. So we have all these Pis. We want to like have a place where you can check what's happening all the time, so we don't have to manually go in each one of them to see what's happening. So there is a couple of things that you can do over there. We want to centralize the logs. They're easier to see. Not only logs, but you can definitely have your API send some kind of events to whatever monitoring tool you're using. So all of them log to the same place, which is our Mac, or whatever box you're using. And definitely we're able to see what failed very easily without having to SSH into the machines. So there are a couple of things that you can use. You can definitely use your homemade custom logs and put them over there, maybe collect them and put them on a folder, and then you have to do some greps and try to find some stuff over there. You have syslog, of course, FlintP, Splunk, also a very good tool about logging, and a few others. But in this case, we end up using Elk. It's a very known tool or very known tools that you do this kind of stuff, and with Kibana it allows you to do the dashboards that we showed in the beginning to monitor your stack. So about Logstash. So Logstash, by the way, is anyone here familiar with Elk? A few, most of you, okay. So who's here is using Elk to monitor stuff? Okay, like half the room. You can definitely use other stuff, but we ended up picking this one. So Logstash allows you to centralize, transform the data, so you're able to just feed in log into Logstash, or basically, it doesn't need to be log, just whatever data you want to feed over there, then you can transform it and put it into Elasticsearch. So Elasticsearch then allows you to query that data and see it. It has a data processing timeline. There's a lot. They have multiple plugins that allow you to use multiple things to filter the logs or where the events. You can have multiple sources. So in this particular case, you're only looking into the logs generated by the servers, like the Wildfly, Swarm, and Tommy. And later on, we're also going to monitor logs that are being thrown by console. And then basically we're going to push these to Elasticsearch so we can query them and see what's happening. So Elasticsearch is just like a search engine to do analytics on that data. So you can look what you're doing over there. We're using Logstash over here because it's already convenient. They already have these stacked together, but definitely you can visit other stuff. So there are some other projects that you can use to fix stuff. They have REST API, and you can definitely build your own API that will push events directly to Elasticsearch. So let's just say when you have that REST endpoint, you can definitely do a push whatever data you want to Elasticsearch directly instead of going from Logstash. Then you have Kibana. Kibana allows you, so Antonio already showed that a little bit in the beginning, but we're going to look a little bit into more detail in demo 3, yes. Allows you to see the data that you have on Elasticsearch, allows you to search for data, allows you to query for data. You can do a couple of dashboards and monitor your server right away. So another thing we're using is Gulf. So Gulf is the Graylog standard log format. We ended up picking Gulf because Logstash has a plugin for Gulf and Docker has a plugin for Gulf. So we were able to set up Docker to push directly the Docker logs into Logstash using both Gulf plugins on Docker and the plugin on Logstash. So it was we ended up using that because it's the most easy setup that we were able to find to push the logs that are being generated by the Docker containers directly to Logstash. And the one good thing about Gulf is that they already provide a structure for the logs, so they already have stuff like the host name that is being generated the log, date and time, IP addresses, the Docker container name, Docker container ID, and we'll see a couple of that in the Kibana. So for the so you have like these Logstash conf. So this is just to tell Logstash how it's going to grab the information. So the input is very simple. So that's where the input is coming from. This is coming from Gulf. This will open up a port on Logstash, and then the Docker container plugin for Gulf, it will just connect to that port, and it's just going to push every log that's generating over there. And then for filter, so this one over here is just a pattern to transform the exception stack traces. It's just in a single event. So if I didn't have over there, all the stack traces will show up in a different event or a different line into Elasticsearch, and then it will be painful to see the stack traces. And well, the output will be Elasticsearch. So Gulf for Docker Compose, it's over here. So you have an option on the Docker command line, and also present on the Docker plugin for Ansible, which is logging. So in logging, you can pick the driver that you're using. So the default driver will just log directly into your file system, but they have a couple of other drivers, and this one over here will just use Gulf, and then you have the address over there. So here is hard-coded for localhost, but when we're doing the Ansible script, we'll just change that to this machine, so it will push directly over here. And let's do the demo. So since I was doing over here, so now it's gonna take a little longer to do the deploy. So I'm on demo 3. Now I'm
You have Eureka running on your machine?
I have Elk running on my box. Let's see if I still have it running. So at the moment I have no results over here. Let's see, there is no results over here as well. Sometimes sometimes there is a little bit tricky. I have to check the date times, but since I'm not generating any logs yet, so the tricky part over here is that sometimes if the Raspberry Pis are not on the correct date, they will send you the date which they have over there. So let's just say they have like 1 hour behind, and then you have to like play around with the date times on the Kibana search to actually find the logs.
Because when the Raspberry Pi doesn't have a battery, so when you plug it for quite a long time, the timing is not right. So it's a bit of a...
But hopefully the network guys just saved us, because we do need wired connection to the Pis. You definitely need to grab like a Wi-Fi thingy to feed the router. But if we have internet connection on the Pis, then they're able to grab the time from the internet, and they will update. So, okay, it didn't took that long. I wasn't hoping that I had to dance to entertain you guys.
But this deployed and starts the application on the Pis. But to be honest, it takes a bit of time to actually start.
Yeah, I mean.
So that's why the logs usually take a bit of time. Is the Angular app up and running?
It should be. Let me just change these for last hour. Okay, I think that the Pis are probably like 1 hour behind. So it's like, or these probably is from a while ago. So let's see if the Angular app is running.
It should be demo 3 now.
Yeah, now demo cool. 3. Awesome.
So this is up and running.
Let's see. So the Numbers API also takes some time to boot up, so it's not up yet. Now, one thing that I would also like to tell you guys about is, and this is, I think, it's a limitation there on Docker. I found like a GitHub issue for that is whenever you set up a logging driver to the Docker container, then you lose the logs on the Docker logs command. So basically, you're not able to have like multiple logs plugins set up on the Docker container. So if I try now on my book API to see Docker logs, since I changed the configuration of the Docker container, now I'm not able to see the logs directly onto the box, which is a bit of an annoyance. Sometimes it might be useful to go directly to the machine to see the logs. But since we have Elasticsearch over here, we shouldn't need that.
The number API is still not up and running?
Oh, there yes, it is. Yeah. Okay. So it's a little bit slower. So just one more detail. So we're actually running the Oracle VM JVM for the Pi. There is OpenJDK as well, you can run it, but it's much slower than the Oracle VM. So for instance, Wildfly in here takes like 1 minute to start up on the Pi, and with the Oracle VM. With the OpenJDK, it takes like 10 minutes. So good job, Oracle. Okay, so now let's see.
Now if you create a book,
well,
we still have the Eve exception, but at least we could see it.
Hopefully, let's see if I yeah, I don't have any logs because I'm probably not generating any logs yet. So let's try.
Yeah, but
I should have like some logs of book number. Let me see over here.
So, is the time right on Kibana?
Let's see. Sometimes it takes a little bit of time to update. Okay, so now we're starting with some real problems.
Until now, it was fake problems. Us making problems, but sometimes we have real problems. Because when we arrived here this morning, the Pis were set at the time of yesterday. But then we managed to plug them to a real cable to the internet so they could synchronize. But still, they're on English time. So they are 1 hour behind us. 2 hours, the UK? God, this Brexit is really hard. Gee, it was 1 hour before. No, it's true. They really want to leave. They want to stick to the American time soon.
Yeah, well, give me a couple of minutes to see if I'm able to figure out what's
Okay,
going on
so
over
what shall
here.
I do then?
Well, can you dance to entertain your audience?
Okay, I can do that. So, no, but I can maybe tell you a bit of story. Roberto is in Portugal and I'm in Paris, so we've been doing that, remotely, doing all that. So I have my pies at home. He has the pies at home. And, when there's a problem, you just have to take the webcam of your laptop and show the pies, see, I can't see the light. So it was a bit tough. So that's why we arrived here on Sunday morning and we just got locked into a room for 2 days. But yeah, it's a nice toy. You can come and have a look at it. But it's very particular. Anything can go wrong. The router, I think we spent more time configuring the router than writing code.
I'll try to check that on the break. So at this time, the logs are not being pushed for some reason. I don't know why, but the idea here is that you will be able to see the logs here on Logstash. So I can show you. So of course, I have this running right before the session, and now it's not working for some reason.
If you want to switch, and we can show my board because it's still up and running since
I
the beginning.
I can show like the my old data over here, which was right before the session. So I'm not able to show the exception because I don't have that. The section I want to show because I don't have that yet.
But what we wanted to show you is now that we have a board, we can actually see the exception.
Actually, I think it's probably just a little bit slower because I see like the Docker generated numbers over here. Okay, let's try
click again. Yeah,
let's try again. So let's do. So this was at 9.
So generate some numbers. See if we see some logs.
Let me just put like 1 hour. No, sorry, that's 4 hours. No, 1 hour. Okay, because I have a couple of them over there. Store. So let's generate
some logs.
Numbers. Okay. So. I think it sometimes takes a while to update for some reason. Oh, I think they're over there. So they are over here.
Oh, so it's 50 minutes behind then.
Something like that. So let me try to generate that exception. Let's do quick last 15 minutes, like 1 hour. Okay, yeah. So they're over there. Okay, so now let me try to have the same exception again. So
create a book now?
Yeah, book. Let's go, create a book. Title, my awesome book. Roberto,
Drama still?
Drama, yes.
You hooked into drama.
Yeah, so yeah, there you go, failure.
So there's a failure, but now hopefully we can go to Kibana and see it.
Okay, there you go, some exceptions over there. So let's try to open this up. Okay, so there you go, connection refused, the one that we were having. And
except
why?
Now it's much easier to look at.
Connection refused, let's expand this. Let's open this log a little bit. And there you go, the local host. So basically I can also come over here and I can say exception. Come on, okay, so now I only have my exception, so it's just easier to search for. So if I know they're having a problem in my code, I have all the logs being pushed over here, so I can just go over there and search, okay, I want to search for exceptions, and now I have the exceptions that are being thrown by our book API because not able to find the the number API host name. So there, now you're able to see the exceptional. Not sure if you're able to see it. Not sure if I can increase this a little bit. Yeah, okay, but yeah. So there you go.
Switch. So finally, we see some logs. But what's the problem? The problem is we've used fixed IP addresses. So there's plenty of way of doing that. We actually configure some IP addresses so we can change them around. But we also played with the hardware when we customized the router to load balance using alias. So we are going to show you what we did in terms of configuring IP addresses. So where are we? Book API has hard-coded IP addresses on number APIs. We have several environments. So we have localhost on Mac, but we also use Docker Compose because it's easier. And we have the pies. So we need to configure those hosts. The architecture is the same. So now we're just going to make it run, hopefully. Code configuration. We need to configure parts of our code. There's business for config. If you deploy one app in one country and to the other one, you might want to configure the VAT rate. But there's also the technical configuration. That's what we do. So we have different environments, different IPs. We're also going to use a timeout later to show you when things go wrong. So all this is configurable. How do we do that? By hand, with environment variables. That's quite a good one, actually, when you boot an environment. Property files, of course, using XML, JSON, or YAML. The database is also one thing. JNDI, if you come from the Java EE world, or Consul, or Eureka, or things like that. Spring config. And because we used the micro profile, we took the configuration bit of the micro profile. So the way it works, the micro profile use what we call the configuration sources. You have several sources, the database, the property files, and the property, the same one, can be in different sources. Okay, so you can say, first grab the property IP number on the DB, and if you don't find it, take it, on the file, and if you don't find it, apply a default. Basic stuff. And the good thing is you can change that at runtime. So your environment is running, and you can change things on the fly without restarting the app. So that's what we did. Remember our Feign client? The Feign client has a hard-coded IP address. Now we slightly changed it. We said we use the config of the micro profile, and we said look for a variable called number API host. If you find it good, put it on your base host, this one. If not, take the default one. So this demo is we just changed the Feign client to use the config instead of hard-coded IP address. And the good thing now is on the Docker Compose, we can do that. So on local, we don't set it up, so it's local host. On Docker Compose, it's that one, and when we build our image, it's a different one. Demo time.
Okay. Let's see if this works. So I just finished up the deploy for demo 4, so you guys don't have to wait for that. So now I have my store demo 4 over here. Book number didn't start up yet, but should be almost there, hopefully.
Yeah, as we say, Wildfly Swarm is slightly longer to boot because of his Java thing on the Pi.
Well, now you should actually see some of the wildfly logs over here as well. So let's see what he's doing.
So it's set up at 9.
Wildfly swarm is ready over here.
Oh, okay, cool.
So
Wildfly Swarm is ready. So we should have the numbers now.
hopefully.
Yep.
There you go. Okay. So I was not able to create the book a while ago. Let's see if I'm able to create the book now. Oops. With this Limo 4. So let's go to the books again. So, oops. I shouldn't have done that. Okay. So let's go to books. Let's create a new book. My awesome
Again.
book. Yeah, I really want to write a book this time. So let's throw it like 250, maybe. Saturday this time. So let's hit save. Oh,
Yep.
awesome!
Come on. So it works because now it's localhost on my machine, and there we have configured the IP address. Good. But we're going to move things around. No, this IP address is configured, but still fixed. We are saying Angular on Raspberry Orange, please go to the book API on Raspberry Red. Now we want to move things around. We want to move our services from one Pi to another one. That's when we're going to add a registry. Registry. So we have two microservices, book API and number API. Can be deployed on any Pi. So, it can be on one IP or the other one. How do they look for each other? So now it's a bit sad. There's the image is plain QML is cool, but it's difficult sometimes. So there's the ELK at the very bottom. Okay, we're introducing this purple box, so it's going to be on the purple Pi. It's console, so everybody, including the Angular app, will register on console and look for the others on console. And ELK is still at the bottom. Okay, service registration and discovery. Think of it as a DNS. I need to ask someone, where is the other service? A service now registers with an ID, a name, an ID, and then I will look for this name, not for an IP address. And another service looks for it by the name. And we will see later that we can have several instances of the same service. How do we do that? How we do register and look for things? Well, if you come from Java EE world, there's JNDI. It has been on for 20 years now. Zookeeper also, Eureka. But actually, we didn't take this one. Very hard to set up. We took a console. Eureka, as we said, we use most of the Netflix stuff, Feign, Hystrix, Ribbon. We found this one a bit difficult to set up. And to be honest, Netflix makes money out of movies, not of code. So the documentation is poor, everything is poor. So sometimes you eat a wall. So in our case, we took console in that case. What is console? A solution to connect and configure also applications. So console, you register each other, but it's also a key value thing, like JNDI. So you can put config into console. It's distributed and available. We only have one console, but we could have several and plug and unplug one. So actually, your console is our SPOF. There's only one, and everybody needs it. So if you unplug one cable, everything dies. But the console can be distributed, and you can have different instances. You have runtime configuration and so on. So there's two things that you need to do. So all our services need to register. And that's, again, is quite easy. You have the console, a builder with an agent. And once you have it, you do two things. You register your service with a name. So here we put a number API name. And then the good thing is you can give a check. So here we have an HTTP check. On each of our service, we have a health check that goes, I'm alive. And console will ping those endpoints every 10 seconds. So in console, I register myself, and I tell console, please ping me at this endpoint every 10 seconds and see if I am alive or not. That's when we can start to plug and unplug cables, because the console knows who is up and who is down. So step number one, I register to console this way. I give him an else check. So in this case, we in our number API and book API, we just have an else check and return the 200. Very easy. And then the book API needs to discover the number API, giving a name. So again, I use the console builder. I ask him only the health clients. You know, I don't want the clients that are dead, not answering. And here I tell him, please give me all the healthy instances of the number API, giving a name, not an IP. And then that gives me a host, and I use feign with, you know, here it hasn't changed. I use feign, giving a host name, and this host name is given by console. Okay? And we have a lovely board that we're going to show you. The console comes with a nice board. Demo time.
Okay. Okay, guys, so again, I already deployed things for you, so you don't have to wait. So in here now you have our store, which is demo 5. We didn't change anything dramatically over here, only where we're going to retrieve the servers from. So the book API, I'm not sure, I think is not really working right now. But the idea here is that now here is the console. So every time a service comes up, it registers on console over here. So now you're able to see, for instance, book API is here. Let's see, yeah, number API, I think it's dead. But now you're able to see that the book API is over here. It's running, so we can see the health checks that are being performed over there. And when number API comes up, it will also be registered. Oh, there you go.
So it's orange because it's up, but console hasn't made a call to the else check.
Yeah, now it's green.
And now it's green because it contacted the health point.
Yeah, so number API is a little bit slower to start up. Now we have both services here registered on console, so we're able to see whenever they are up or down. So now if I go back to my app, I'm able to retrieve book numbers again. And hopefully, if you go here to console, so book API is running on one of these red ones, so just gonna unplug these ones over here. And if I refresh, whenever it does an else check, it will...
The else check is every 10 seconds.
It will hopefully say it is down. Or maybe it's longer.
Are you sure you've unplugged the right one?
I'm pretty sure. There you go, it's orange now.
Oh, yep.
So now it's orange, so if we go here on the detail, you see that the health check is failing. So of course the server will not answer for that. Now if I plug these guys back in again, And hopefully console will detect that's up. Oh, it was much faster now. So now the service is green again, so I'm able to use it properly. And again, if I come here to my book API, come here to
Create
book.
an awesome book.
No, probably not so awesome.
Oh,
Awesome book.
that's a drama.
Yeah, that's a drama. So let's probably do it on 2020 now. Drama, hit save, and there's my book again. So yeah, on the application itself, it didn't change much, but now the using console to do registering the services and then look them up is something very important on the microservices world, because now it's easy because you only have one of each, but when you start to have multiple of them, you need to know where they are, and it's kind of unreasonable to have to pass in all the servers that you're going to use on system properties or environment variables or wherever.
Ladies and gentlemen, let's have a 20 minutes break. And when you come back, we hope you will come back. We will
Hopefully.
talk about circuit breaker because we're going to unplug things. We have to fix that. Scaling, we will use other pies. Security, because you always need that. And load, so we will put pressure on the pies. See you in 20 minutes.
Thank you, guys.
Whoops.
Okay, we're back. Thank you so much, guys, for returning to our session.
Oh, oops.
Oh, okay.
Thank you for coming back. So there's 1 hour left. Now we're going to start playing with failure and scalability, security and load. So at the very end, the last demo is we'll put pressure and we'll unplug everything and everything will work.
Hopefully.
So let's talk about an important pattern, the circuit breaker. We have 2 microservices. Okay? Book API calls the number API. But number API can fail. How does the book API handle this failure? The architecture doesn't change, but now the book API needs to be clever enough to say, I'm calling the number API, it's not responding, what shall I do? Well, you can use a circuit breaker. So, when services collaborate, mostly in a synchronous way. When it's asynchronous, you can handle it in a different way. But when they handle synchronously, things can go wrong. Either the service is not there, or the box is totally under load. We're going to simulate that with a timeout. So the service is there, but it's bloody slow. What do? Do you wait? And if you wait, so if that's what's going to happen, the number API will be slow giving you the numbers. If the book API hangs, well, now we have another one hanging, and the client will hang, and the entire chain hangs. So that's why it's called a circuit breaker. You should open the circuit. How do you do that? How do you use this circuit breaker? You build your own. Actually, when you come from the Java EE world, there's a few implementation using CDI. There's another one, but it hasn't been maintained. It's called JRugged. The micro profile actually has one, or will have one in the next version, the 1.2, I think. We will be using Hystrix. Again, as we said, we use Feign client because Feign integrate well with hystrix and ribbon that we'll see later. What is hystrix? Well, it's the Netflix implementation of the circuit breaker. And the way it works is you construct an hystrix command. We won't be even doing that because the command can be complex, and as you will see, ours is quite simple, so we don't even use it. But the idea is you create the command to execute. So I want to call the book API. But instead of invoking it, you invoke it in an hystrix command. And then you execute this command, meaning if it's okay, it will go to the book API. So the hystrix command is clever to see if the circuit is open or not. If the circuit is open, so meaning, there's a failure, it will do something else. If the circuit is not open, it'll proceed. Oh, and integrates with Fein, as we will see, with the Fein hystrix client. So this is our number API failing. We will, of course, unplug a cable, but here we configure a number of seconds. So here there's a fake timeout. So again, we use a microprofile configuration to set it to different values. And we wait. So the service is here, but it's not responding. So that's the number API failing. Now the book API needs to fall back. Remember, we still have this API client builder, so we use Fein to create a builder to give us a proxy to the number API. So thanks to the console, as we saw, we have an IP address. And as you can see here, this is our hystrix command. Because it's just a one line, we didn't have to put it in a command. But what we are saying is, here is the fallback. And the fallback, in our case, returns a string. And now, instead of using a Fein builder, client builder, we use a hystrix Fein builder, and that's all. We do the same thing. Console gave us the IP address where the number API is, and we just pass the fallback. So the magic here is hystrix Fein client, the fallback, and we give it here. Meaning if we call, so if the client called the number API and the number API is not there, our book number will be fallback ISBN number. And then we have to do, something else. The good thing is the entire chain will keep on working. But then in a business point of view, that's different. Maybe in a business point of view, I have to go back in 10 minutes and take the fake ISBN numbers and change them with a different one. Again, in terms of a business, it can be quite complex. Technically, it's just a few lines of code. Demo time.
Let's go. So far, the demo gods are being merciful on us.
And we have 24 gods.
Okay, so let's go to demo 6. So now, as you can see, I'm on demo 6. So let's go over here on my numbers. So I'm able to grab the number. That's fine.
So if you create a book, it will work.
I'll get. So all the nodes are healthy over here on console. So let me go and create a book. So let's see, boring book now.
You can write that now.
I'm going to write it this year, definitely. And a romance. Yeah, that seems fine. Save, okay.
So the book number is BK, so it's a book number.
So yeah, so basically there was nothing new over here, so it was just creating the book as we did on the other occasions. But now let's do something interesting. So I'm not sure on which one.
Unplug them all.
No, I'm pretty sure that there are these ones over here. the ones on top. So I'm going to unplug those two pies. Let's go to console and see. Okay, so now one of the books or one of the number APIs is not running. So let's go back here to my store. So if we go to the numbers and we try to retrieve a number, we're not getting any response back. So the request is just waiting for something. But that doesn't mean I'm not able to create books anymore. So if I go, as Antonio is telling me, now we have the secret bracket over here. So if I try to create a new book, so let's call it the boring book version 2. And I'm going to be the author, of course. Now it's going to be released to be next year. And it's going to be Romans again. So let's hit save. Yeah. So now we see that we fall back to the fallback ESPN as Antonio showed on the code. So now the service is down. That doesn't mean they're not able to create any books. Of course, we can discuss that that's not the correct ISBN, but you can make it much more smarter and actually generate a real one if the service is not really running. Now, if we plug these guys back in again, we should get back our number API. So let's look into console.
So you didn't set the timeout on the number API to wait for a minute or something like that?
No.
Nope.
So yeah, now number API is back on over here. So if we go back to our store and go to the numbers and we try to generate numbers, we have numbers again. So hopefully if we create a new book.
Oh, and if you edit it.
Sorry?
No, we didn't implement that.
Yeah.
No, I thought you just edit the book, change it, and we'll have a nice B address.
So let's say boring book version 3, and the author is going to be that year, another romance. Save, and now we have
Cool.
back our ESBN coming from number API.
And we will actually use that later. On the last demo, we'll push pressure on the pies, and we'll plug and unplug things. And the idea is that the entire application should keep on running, and we will see a lot of fallbacks.
Okay.
Okay, so what's next? Well, we have 24 pies. So far, we've been using 2. So let's scale the architecture. And you will see that we're going to need a load balancer. So we need to scale our microservices. You know, a lot of people are buying books. So the good thing with microservices is now we can, you know, the architecture is completely stateless, so we can have as many as we want. So we're going to start scaling the number API. So we still keep one book API. Now they still have to be registered. You know, we're going to have 4 number APIs running on the orange. So the 4 instances need to register on console. They are deployed on 4 pies. Which instance to choose from? The 4 pies are registered in console. Number API 1, number API 2, 3, and 4. What is going to do the book API? The book API needs to pick up 1. So that's how, you know, the architecture is going to look like that. And now, on the red bit, on the book API, we need something clever to first go to console and take the 4 number APIs, and there's choose one. That's what we call a client-side load balancing. So we have several instances of the same microservice. And the idea is console gives you all the healthy ones. It doesn't tell you keep this one, you know, take this one or the other one. So the client, the book API, gets all the instances, the 4 instances, and then choose among those 4 instances. Which one? And that's when load balancers can be more or less clever. Which one will I choose? Well, round robin, pick number 1 and then number 2 and then number 3, or things more clever. If you have different data centers, you can say go to the first one, and if something really goes bad, then go to the number 2. But as you can see now, it's the client choice. Console is just there to give you all the instances. How do we implement this client load balancer? Well, choice number 1, you can do it yourself. If you are on Amazon, they have their own, but only works for Amazon, as far as I'm concerned. Then you can always, use load balancers and do the trick. So HTTPD and Jinx also does that. We are going to use ribbon, so we're going to rely on the Java code, not on the structure. What is ribbon? The Netflix, again, implementation of the client-side load balancing. So it's quite a clever beast. You can, again, a ribbon can talk to other ribbon instances. We use HTTP, but it can support other protocols. And we use a synchronous model, but it comes also with an asynchronous and reactive model. And it has caching. So he also tries to cache things to be a bit clever, to not, try to pull all the instances each time. And the good thing is integrates with Feign. Feign is from Netflix. As you can see, Eastrix was just 1 line of code. And ribbon slightly more complicated, but on the Feign side is quite easy. So the first thing, before we had 1 instance of the number API, so we registered in console giving a name and no ID, so it was ID 1. Now, ID has to be unique. So what we do is we still register the number API with the same name, because we want to ask a console, give me all these instances of the number API. But now we must have a different ID for all these instances. So we use the UUID. So when we register our services to console, now you will see a random ID. That's the different. Do you want to explain
sure.
This one?
Yeah, definitely. So for registering the ribbon load balancer into your book API, so what we do is we start up with the ribbon round robin rule, so we can have a round robin load balancer, and actually we're going to use something that they call a dynamic server list load balancer. So dynamic server list load balancer is something that basically updates its hosts based on a rule that we might have. So this is just to have some setup. And then we have a configuration that allows us to say, hey, we're going to refresh all the servers in each 10 seconds. So each 10 seconds, the ribbon is going to try to update the servers. But we're not going to do, so ribbon's not going to do a health check. So what we're going to do actually is we're going to call console to give us the healthy list of the hosts, which he already has because console is doing the health checks for us, and it can retrieve us the healthy list of the servers. So now in here, I'll just registering my load balancer, and I think we're missing a little piece of the code here.
No, because we need to register the load balancer, so there's code invoking this one. Yeah,
and I'm saying the server list, the one that I'm not sure if it's over here. Never mind, I'll show that really quick over here, hopefully. So this one is on demo scale, services book. So it's just like a little piece of code, but it's actually important. Resources, REST, console management. Presentation mode. Oh, it was already in. Okay. That was the piece I want to show you. So basically, we register here something called the number APIs, which implements a ribbon interface. And here it just has two methods, one called getInitial servers and another one called updateList servers. And these are the methods that ribbon is going to call when it starts up, the initial ones, and then it will call the update list of servers each 10 seconds. And while in here, we just don't care, we just called the initial one over here. But what the initial method does is it just do a call to console to grab all the healthy services that are available, and then it will feed that into Ribbon. So Ribbon always has the healthy list of servers to pick from. Yeah, sorry about this change.
I was updating the slide on the fly.
Okay, but I think that yeah, we don't have anything. We don't have much more. But then, how are we gonna use this load balancer with our call? So, as Antonio mentioned, we have there is a project or a module in Feign which does integration with Ribbon. So it's very easy to use. You still use the district's Feign builder to have the fallback still, but instead you're gonna just wrap your call into this load balancing target, and you're still gonna put whatever endpoint you're gonna call over there. But now notice that the endpoint that we're calling is something called numbers-API, and if you notice,
we could have called it foobar.
Yeah. And if you notice over here, we have something called number-API. So what happened is when we register the Ribbon load balancer, it will be registered on virtual HTTP hostname called number-API. So when Feign and the Feign Ribbon is calling our number API, it will look for a load balancer register on this host name. And okay, now I have my load balancer, I'm on Ribbon, so now I have all this list of servers. I pick one on the round-robin algorithm, and after I have one, I'm just gonna rewrite this address with the actual host name of the server that I'm gonna call. And yeah, let's do the demo now. Okay, so now we are on our store again. We are on demo 7. So we didn't change anything in the app, or at least on the UI side. We do change a little bit on how we call the book. So I already do all the deploys for you guys. As you can see over here, we have a couple of other changes. So now not only I updated all the other, so the Angular, the book number, and the number API, but number is now deployed on 4 pies. So now we have all the orange ones are running number API. So if I show you console over here, so all the servers are up. But if I expand this, then I'll see that I have 4 services running. So hopefully, if I'll disconnect one of them, one of them will go orange. Should I put like a smaller timeout? Okay, so now one of them is orange, but that doesn't mean I'm not able to create books with the right book number, because we still have 3 endpoints, we have 3 servers that are still giving us the number back. So if we come here to our bookstore, let's go to the books again. Let's create the book. So boring book. I'm the author. Let's put it on 2020. Doesn't really matter. Save. I still got the right, still got a book number over there, so that worked fine. Now, if I do unplug a few more, so let me unplug this one, and let me unplug that one over there. So let's go to console again. So hopefully console will update. So now, yeah, so now you already noticed one of the hosts is down. So it's not going to give that host anymore to Ribbon. So now 3 of them are down, but I'm still able to create books. So I'm sure that you'll believe me, but now let's do it much quicker now. Doesn't matter. So I still got the book number correctly. And of course, if I disconnect the final cable, so I don't have any number APIs anymore. So let's look into console to see when that is down. So still up, still didn't notice. So now all of them are down. So
and in Kibana, can we see anything?
yeah, in Kibana we can see some things over here. So we do have what happened? Okay. So in Kibana we do have here a dashboard, and basically if you'll see, let me try to increase this a little bit. It doesn't look very good, but as I can see here we have this gauge that basically is counting the health checks that were okay. So at this time it's on res because we don't have any number APIs left. We still have a few counts because we're also monitoring the book API, and the book API is running perfectly because I haven't disconnected the cables for it. But now if I come over here, sorry, I'm always messing the tabs out. So now if I create a book over here, this will go to fallback my ESPN. If I connect, let's connect 2 of them.
What if console is down?
Sorry, if console is down, yeah, we'll just pack our stuff and go away.
No, that's what we said. Console is actually, you can distribute it as, have several instances. They do health checks all together.
So console will work the same way. So you're able to have multiple console instances, and they will update with each other. They will share whatever is up. So for this to not overcomplicate things, and because we didn't have that many pies, we only had 1. But we can definitely have 2 of them, and if I disconnect the console one, you'll still have the other one to give the health checks. So
yeah, console becomes SPOF. So you have to be careful, because if every time you invoke, one microservices, and you can do that several times a second, then your console or Eureka or something else become a big SPOF. That's why you have to distribute it too.
Yeah. So now, as you can see, my gauge is yellow. So it does tell me somehow that I do have my cluster seems to be more or less working, but I might have some failures. So now, since I have the other 2, I'm still able to create books with the proper book number. But I definitely have 2 services down, but let's just plug these guys back in, and hopefully our cluster will move to green, so it's already increasing a little bit, and all the cluster will be fine. So if we look into console now again, let's do a refresh over here. Okay, so all the number APIs are up, and now my gauge now is approaching the entire green number to see that everything is healthy and everything is working fine.
Good.
Okay.
So we've scaled number APIs. We will end up scaling book APIs. But there's one thing we still do. Securing microservices. Oh,
yes,
yeah,
sir.
Sorry, one question?
Why did you decide to do client-side balancing? Because you already have console and console can do service-side openings.
We're going to have server-side load balancing as well in this demo, or actually the other demo. We're just trying to show like multiple ways to do things.
At the beginning, we wanted to use all the Netflix stack. Eureka was a bit of a pain, so we changed that bit. Like console, you can do a configuration too. So we could have put our config into console.
Well, but it's microservices, right? You should use all the things that you can use.
Yeah, yes. Okay, so now we're going to add security on the book API. The number API is a public API. Anybody should be allowed to use it, but not the book API. We're going to secure the HTTP post, put, and delete, not the get. Security. Number API is public. Book API, gets are public. Post, put, and delete need authentication. To make sure that each time someone in the cluster invokes HTTP post, we need to centralize those requests. We're going to use a gateway. So this gateway will filter, all the requests will go through the gateway. And this gateway will go, this one can pass, this one can pass. Oh, not this one. Okay, so the gateway will configure the gateway on the URLs and the verbs, and the gateway will say, oh, you want to do a post on this service, give me the token. So we're going to add a purple box called the gateway. Again, the gateway in our architecture is a SPOF, a single point of failure. This gateway, like a console, should be distributed, just to make sure it doesn't fail the entire application. So we're going to put the gateway in the middle. And actually, it's not completely right. It is in the middle. We put it on the top. But again, PlantUML was giving this diagram. But the calls between the book API and the number API go through the gateway. The diagram is not that correct. So the idea of the gateway is we need a centralized place where all the requests go. Think of it as a proxy. And those services are exposed through this gateway. We call the gateway first and then the endpoint. And the gateway intercepts the request and goes yes, no. Apply authentication. Several gateways to choose from. Again, if you are on the Amazon world, they have the Amazon API gateway, APG gateway. We use the Tribe Stream Access Gateway because he's from Tommy Tribe, so it was good to have access to all the R&D guys. So do you want to talk about it?
Yeah, sure. So it's fine. So the Tribe Stream Access Gateway is one product that. So I'm not trying to do this like a pitch sale. But basically, Tribe Stream Access Gateway is a product that Tommy Tribe has been developing over the last year. And the idea of the Tribe Streams Gateway is to allow to make API security for microservices. We pretty much support OAuth2, JOTs, HTTP signatures out of the box. So the idea is that you're able to secure your microservices using any of these security approaches. We allow you to route your microservices, so you can pick whatever security you want using routing. And we also have a load balancing in there, so to support server-side load balancing. The JSON Web Token, I'll put that to you.
Well, if you don't know what a JOT is, the idea is we authenticate with a user and password, and the gateway will give us back a JOT. And this token is lightweight enough to go back and forth, back and forth, back and forth. The good thing is with this token, you can put some data in. It's not like a cookie. It's not just a random ID. You can actually put data in it. It's encoded in base 64 and can be encrypted as well. And the idea is you pass this token on every request. This is a token. So this is what you have on the HTTP header. So in the authentication header, you have this bearer. If you look carefully at it, there's dots, so it's actually made of 3 parts: the blue, the orange, and the green. And because it's base 64, we didn't encrypt this one. Well, it's just plain text. So the blue part, the header, gives you the algorithm used to encrypt. Then you have the payload. That's where you actually can put data. Here we put the subject. So when I log in, there's my name. The issuer is the gateway, and then it can expire in 1 minute or in 1 day or in 1 year, and you can put as much data as you want. The idea is still to leave it light so we can go back and forth, and the signature to verify at the end. So the Angular, here I'm showing you the Angular app. What we're going to do is now we have a screen where we enter the user and the password. It will go to the gateway, do a HTTP post, and the gateway will bring the token back. So on the TypeScript side, we pass the username and password in clear, I know. But the idea is when we do this HTTP post, we pass the login and the password. The gateway receives this post and goes, yes, it is the right guy, and sends a token back. So here I take the token out of the header, and I'm going to do something, pretty easy. I'm on the browser, so I will just stock the token on my local storage in Chrome. One way of doing it. So when you log out, it's actually deleting the token. The token will eventually expire, but that's, I'm killing the token on my Chrome. So that's the Angular part. Please give me a token. And then I need to pass this token around. When I do gets, if I want, not in our case, but now I will get the JOT token that is stored on Chrome, and I will add this token to the authorization header. And then I will do a delete. I want to delete that book. And I show you the token. So I should be allowed to delete a book. Roberto, demo time.
Only 2 left, and so far so good.
So you're going to show us the gateway, how to configure it?
Yeah.
So the demo 7 now, if you want to create a book, it will fail.
Yeah. So let's do that first, probably. So I'm here with my demo 8 now.
Oh, 8. Sorry.
Yeah, demo 8. So again, I'm still able to.
The number API is public.
Public is public. I'm able to call it. Books. Well, let's see. Let's see if I'm able to create a book. So I'll just put something simple now. Let's clear this out. Let's hit save. Okay, now I have a 401. So probably it's not really very visible over here.
Because it didn't log in, it has no token.
I got a 401. So in our application, we are able to retrieve books and get books. So I'm able to see the book.
Oh, you
over
actually
here.
have an old token that has expired.
Yeah.
Log
probably.
out.
Oh yeah, that's right. So
log out.
That was a very interesting thing. So I was already logged in, but I have an expired token. So yeah, but you can do that same again. So I'm able viewing books and seeing the books list. You're able to do that. But of course, creating a book
and deleting a book.
And deleting a book. So again, I got the 401 over here. So now, how do we do this? So as if you notice, we didn't add any authorization code on the microservices. So the idea here is that the gateway will handle that for you. So for that, so we'll be able to do that instead of calling the service directly. You're going to proxy the call through the gateway, and the gateway will apply the authorization to you. And if it's able to pass the authorization, it will call the service back, and if not, it will return you a 401 or a 403 if you don't have any roles. So as Antonio was saying, we're using JOT, so we do have something here what we call the security profile. So on the security profile, we're able to have we're able to say how we're going to generate the token. So when Antonio is trying to grab a JOT token, he's going to do a call to the gateway. So the gateway will return him the token. So in here, it's just going to have like a simple token. That's the token endpoint where you can retrieve that, and we're not going to require the client ID. But it still requires a username and password. So in that, for that reason, you do set up here an account. So there is Antonio account over here. You can set up a password for him. Also, any kind of public or private keys as well. But you also have to grab the accounts from LDAP, any database, or any other APIs that you might have. But to make it easier, we'll just have the users write into the application. And finally, we have here what we call the route. So this route is called like book API. Not sure, yeah, I think you're able to see this a little bit. And here I'm going to use this mod rewrite syntax from Apache. I'm not sure, is anyone familiar with mod rewrite? Yeah, a few of them, so you probably recognize all of these. And I'm creating some rewrite conditions over here saying I'm actually missing the delete one over here, but it doesn't matter. Basically, I'm saying if my request method is a post, or if my request method is a put, then every address or every call that I'm being called to /books, I'm going to call book API /API/books. And you've probably noticed over here this API column / book. This is our way to do load balancing. So let me just go over here. So this is the server-side load balancing that I was talking a while ago. So we have this something called connections. We have the book stuff. And I can set up here the load balancing. So here I'm now load balancing the book API between these two pies, the Thrall load balancer and the Grom load balancer. And in there, on that particular route, I'm able to say, okay, if this condition passes, then call this endpoint on this load balancer, and the load balancer will handle whatever host name it needs to call. But how do we apply authorization? So the mod rewrite has these flags that you can apply to a rewrite rule. So in this particular case, we have a P and an A. So for people that know the mod rewrite, A doesn't really exist on mod rewrite. It was something that we added. And P is for doing proxying. So as the A is to apply authentication and authorization. Here in the bottom of the page, now you can say, okay, I did create that security profile for the token, and here I can say I want to apply the OAuth over here, and when I set this flag A, it means that it will apply that particular token authorization to that particular rewrite rule. So in the end, it will mean that for every post or put, this will be applied, and I want to apply this authorization. Also, we have this basic auth profile that I'm using for. So the one that the Angular client is running on the tokens, and actually the loading that we're going to do is actually just doing a basic auth. So you're also able to say I have multiple security profiles, and then I say I won't require any of them. So as long as you're able to authenticate on any of them, the proxy will give you a correct response, or you can say all, and you have to authenticate on all of them. Then finally, since you still want to have people going to the public API, which are the list and the get, I did apply the exact same rules without the authorization flag, and I just have like an exclamation mark over here, so you can negate the method name. So if it's not a post or if it's not a put, so meaning if it's a get or a delete, which basically is wrong, so I'll have to, if I come over here and just copy this and put a delete, it will work just fine. But basically, that's the idea. So now, if I'll go again to my demo, and let me sign in. So let's sign in with Antonio. I think this is the password. I'm going to log in. So this will call this auth endpoint, and as you can probably see over there, you have the token that was given back by that endpoint. So now let's go again to the books. Let's try to create one. So just going to make something really quick over here. Hit save. And now the book was created. It went through the proxy. The proxy applied authorization. Authorization was OK. It went to the book API. Book API called number API, retrieved the book number, and then we have it in our store.
Yes.
Only one more, and still didn't break.
Yeah, we're gonna move to the final demo. You remember the Jimi Hendrix on stage burning his guitar? That's what we're gonna do. We're gonna burn the pies, and it will keep on running. No, now it's just the final demo. So actually, we're gonna stress a little bit this architecture for a few minutes. We're going to add clients. You know, we have a UI to show it's beautiful, but now we're going to add clients to handle a bit of load. So this final demo, we have microservices all over. They depend on each other. They have several clients. So I'm not talking about the Angular. The Angular is there on the black one. We're going to introduce 3 clients, so on 3 pies, that will randomly do HTTP GET, POST, and DELETE. Several services, and things can go wrong. Things always go wrong. So this is the way it looks like now. We have the 4 client tab, at the top. One is Angular, and the other one, the 3 ones are just Java client pushing. We actually put 2 book APIs, 4 number APIs. The console is there, the Elka is there, everything is there. So I think we should, if my demo is still up and running, I might have a few logs. I'm on demo.
Yeah, you were on demo 9 already.
Yeah,
so.
I was on demo 9. So
I'm still deploying mine. So
yeah, the demo 9 is still there.
okay.
I actually the clients. So
and you probably guys is not able to see it, but all the blinking, so all the flashing lights are blinking over here. Router, switches, all the Raspberry Pis with all the loads going around.
Console is still there. Kibana is saying that.
Okay.
Yeah, so there are things happening. I have the same board as you with the same routes and everything.
Yeah, so the demo, actually the demo 8 is exactly the same as demo 9. It's just that we just put more services around on all the pies. And we have clients having loads.
So sometimes we don't see books. Because,
there you go.
There's one. Because our clients are creating and deleting books, and it looks like we are deleting a lot of books. More so, the number API still working. Books has been deleted. I thought we had fixed that a little bit.
Well, sometimes you get some books, and
we try to create more books than delete books.
So the loading clients are basically doing get, post, put, and delete operations, and you're able to see them right here on this dashboard with those status codes.
Explain us what's up there.
Are you able to put this a little bit bigger, maybe? Command plus, yeah.
Yep.
Okay. So what we have over there, apparently PyGram server 1 is having too many calls. But anyway, so we have this on your left side. We have the number API per host graph. So basically, all the calls that are being made to the number API to retrieve book numbers are being logged over there. So for some reason, maybe, I don't know, maybe it was a hiccup or something, but the load, okay, now it's probably load balancing a little bit more because we're using round robin. So remember when we had the Netflix round robin with ribbon? Oh, now it's perfect. Awesome. So basically we're load balancing between all the number APIs to retrieve the number. So in there we have the calls that are being performed over there. No? No books?
Still no books.
Well, sometimes they get books, sometimes they remove books. I thought that
I'm not logged in.
Yeah. Well, never mind. Maybe you didn't update the code.
No, I need to log in.
Okay.
And now, if I create a book, should be there. Yeah.
Yeah, it will be deleted right
and
away.
It will get deleted because the clients are a bit hungry.
They don't like to have books in there. Anyway,
so that's the number APIs.
Yeah.
The number, and on the right side here.
Yeah. So in the bottom we have the amount of calls that are being performed to the number APIs. So basically we're roughly creating 17 or 18 books per minute. And then basically that also means we're also deleting all the books per minute. And on the other side, so we have the status codes of the clients that are calling our cluster. So most of them are 200s because those include the get by ID that we are doing and find all to have the entire list. And then you also have the 201 for when you create something. But we also done one interesting thing, which was we set up our load to try to generate a couple of different addresses. So that's where you have the 404s, and of course we also have a couple of clients that don't have any authorization on the gateway, so they will throw 401. Sometimes you'll see some 403s over there because there are clients that don't have any roles. So there is the role things over as well. So now you disconnected the cable, right?
Yeah.
So now we shall see the load balancing. One of the servers should disappear from here. So you already see that this PyGram server is shrinking. So now it's even more.
So I unplugged two number APIs.
Okay, you unplugged two number APIs, and you also see that our gauge is also decreasing. So now it starts to yellow. Yeah, now one of the number APIs is gone. Now we only have 3, so one of them will go away as well. So that one, so that PyGram server 1 is also going to go away, and the gauge is also decreasing.
So if I unplug all the number APIs, the book APIs should still work because we are falling back.
Yeah. So you're still going to be able to see 201s and still able to see the 200s. So now the amount of books being created is cramming really low. Well, actually, we're still creating books, but we're just counting the number API calls. So we should have counted the fallback as well.
Yeah, if we go back to our web, still no books. Terrible.
Yeah, let me see if
a
mine
lot
is
of
better.
the ring too. So now I have a fallback. Okay, so the application still works. The clients, God, as soon as I create a book, it gets.
I think let me change to mine. I think mine has latest code.
Oh, that's better. Look,
a little better.
Yeah, it's better.
Oh, okay, it's better now for you.
So, yeah, well,
okay. Yeah.
Don't know why, but it's creating a few books.
Yeah, it's pretty random, so. You have
but as you can see, they're all fallbacks now, and so I'm gonna plug those guys back. So book API. Which one do you want? Do you want me to unplug?
Don't say the purple ones.
Console.
We didn't try
gateway. Now we can unplug a book API.
We can try the purple one. I have my setup working. If it breaks, we will change to mine. So redundancy.
Yeah, electricity. Yeah. We rely on electricity.
That's right.
IT guys always say, you know, the planet is ours. Everything is IT. You know, there's IT everywhere, but you need a plug.
Yeah, so
Okay,
Let's
time
move
to
on.
wrap up now.
still have a couple of slides left. Just to
Couple of slides.
wrap up.
What's next? Much, much, much more. But we don't have time. Oh, sorry. So, as a recap, we want to quickly go back and show you what we did as a recap, because the architecture evolved through demos. Remember, we started very, very simple. One Angular app talking to a microservice, then the Angular app talking to one microservice who talked to another one. And we thought, oh, we need ELK. Sorry, it's at the bottom because we couldn't see the logs. And our problem was because we need to configure our code to suit all these environments. Then, because we were moving things around, we introduced a registry so we could register the services and look up for them. We introduced histories, so we had fallback. And then with Ribbon, we could have a client load balancer because we deployed the 4 instances of the number API. We introduced the gateway because we need a central way to go, you're allowed to do this and you're not allowed to do that. And we ended up, scaling with clients. We use many of the microservice design patterns, but there's more. And we didn't use them all.
Is that the hexagonal one?
Maybe. Okay, conclusion. Lesson learned throughout this journey. Microservices are hard. Microservices are bloody hard. When again, that's what I do on my day-to-day life at customers. I have a fantastic team of network experts. I have a fantastic team of DBAs, fantastic teams of everything. When we play, because that's just a play game with pies, it is really difficult. The full stack developer, the full stack dev is not born yet and will never be. The integration is very difficult. We run locally with Docker Compose on the pies. We have 2 clusters that are slightly different. The more technologies, the harder. The more languages, the harder. Every time I go to a bloody conference about microservices, you have those beautiful slides saying pick up whatever you want. Hey, integrating Java code in Wildfly Swarm and Tommy was difficult. They don't handle some technical aspects the same way. So imagine, you have one team doing Ruby, etc., fine. But if you are the guy doing all that and supporting all that and integrating all that, it is bloody hard.
It is. And we were full of ideas in the beginning, when to have like Node services, PHP services, and all that stuff. Maybe for next year.
And again, when you go and see a demo on microservice, they tell you the good thing is you have these microservices, it's running well, don't change it, focus on that one. No, it's not true. We know it's not true. The operating systems must be upgraded because for security reasons. The JVM needs to be upgraded for security reasons. Your frameworks need to be upgraded for security reasons and other reasons. So no, this idea of you have a microservice and leave it, yeah, but if one day there's a security issue and you need to upgrade your entire stack, it's going to hurt you back. So what we do at our customers is we use the same POM XML. Everybody has the same versions of everything. It's hard enough. This was hard.
Yeah.
We didn't have databases. No,
we have in memory.
Yeah, in memory.
Awesome.
But one idea was to put PostgreSQL in that. We didn't have complex business logic. The entire microservice thing is your business is complex, split it into 2. Well, my customers don't do it Twitters or don't send emails. They have a serious business case. And splitting a business in two, well, you have to be good in DDD. We didn't have two complex networks. We tried to build a bridge between those two, and we stopped. We didn't duplicate the gateway, nor do we duplicate the console. You must do that. We didn't use asynchronous events, which is also very, very good, but adds complexity, of course. Oh, and testing. No way. No way. You don't want to test that. And we didn't do tracing. That was one of our ideas, but we didn't have time. And rate limit also. One idea was to leave one client doing crazy push and gets and putting rate limit. We didn't do that. But you should. That's how complex things are. And because we were thinking, are we the only two guys who think microservices are complex and we shouldn't do it?
So let me try something here. So for the people that wanted to use microservices before, when we asked you in the first place, who still wants to use microservices? Oh, there's still people. Oh, yes. You're brave, guys. You're brave.
Well, remember to charge a lot of money to your customers.
And I mean, well, we have all these simple things. I mean, it was just like a book and a number API, and we only wanted to sell some books and look what we had to do.
We felt a bit lonely, thinking, are we the only guys going to go on stage and saying, careful, it's hard, while everybody says it's the Holy Grail? So we asked the planet, we asked Twitter. Some people make it more or less explicit.
Yeah. Yeah.
So I don't know if you've seen the movie, but it's actually, I dare you. It's say microservice one more time, motherfucker. But because it was on the internet, he said, how dare you?
It was me. It didn't have a motherfucker in there, so I didn't have to read it. But yeah.
I like this one. One day, microservices will share some libs, and they will be called servlets again. I love this one. Architect's dreams. That fits on one slide. Developer's nightmare. Yes, my customers are not GAFA. I don't work for GAFAs. So, when the business is complex, things are complex. What I'm trying to do now at my customer is actually introduce microservices for performance reasons. And that's a winner. You take the bit that, costs a lot of, CPU, and you put it in another box. And that's a winner. But my customers are not GAFA, so you might not need it. And I will finish with Simon Brown, who talks a lot about that. If you can't build a monolith correctly, why do you think putting a network in the middle will help?
This is my favorite one, actually. By the way, you could have done this as a monolith. It will just...
Yeah.
Remember when you have JSPs and...
Yeah, remember the good old days?
JSPs, one server.
So, of course, there's plenty of advantages. We already talked about it, and I'm sure there's plenty of talks that will tell you how good it is. We just wanted to focus on how difficult it is. So remember, use this type of architecture if you need it, because it brings you advantages. But also it comes
with a cost.
So not because the others are doing it, except if you want to have fun and charge a lot of money to your customers.
Yeah.
Thank you.
Thank you guys for coming. We are already out of time. We don't gonna have any time for questions, but please find us around and we'll be happy to talk to each one of you. So.
And I would like to personally thank Tommy Tribe, who gave me one of those clusters, and I'm not even part of the company. So thank you, guys.
Yeah, our pleasure.
The code is there. So all the demos, all the slides are there. And we will be more than happy to answer questions, write issues if you want.